This is Kate BYP, short video on the Drake TR3 I'll be using in the Classic Exchange contest tomorrow. Classic Exchange, 1300 to 700 Zulu. Tomorrow is Sunday through Monday, and I think again on Tuesday for phone. And then there's two more dates. I think it's next Sunday and the next Tuesday for CW. This is a real contest. Normally I won't operate contests. They have no purpose. But it takes some real skill and some effort to fulfill the purpose of this Classic Exchange and the Novice Rig Roundup, and that is to use old equipment. And we just don't dig this old equipment out of the closet and use it. Very often it won't work. So we have to restore it and repair it. That's real radio. For those visiting from the Classic Exchange, there's never been and is no other Drake rig that works like this. This is one of a kind. It's been spanning a 7-year project, about $3,000 in parts, including excess tubes, $840 crystal order for sideband filter crystals, probably 3,000 hours of work or more, 350 pages of documentation to totally remanufacture, not restore, totally reverse engineer and re-engineer and modify this rig. Again, there has never been one like this. It is the original intent of a Drake line, and it's been perfected. This is now a full sideband CW and AM transceiver instead of manual switching on CW and AM. That'll destroy that switch. The VFO mechanism is entirely new lead screw precision lead screw nut, commercial bearing units, high precision stuff. The VFO warm-up drift has been reduced to 30 seconds instead of 30 minutes. That was bad wiring and some bad components. Transceiver incremental tune by what was a sideband switch to fine-tune the VFO. It didn't work as RIT because I had no other place to put an RIT off-on switch, because this is the transceiver tune and push poles for sideband, and I will not drill a hole in that panel for any price. So couldn't use RIT. That left no way to align, receive, and transmit. The power supply is entirely new except for the chassis, line cord, and transformer. All the state-of-the-art components are under the chassis. On top are two high-tech AC to DC switch mode power supplies, extremely tightly regulated, less than 1/10 of a volt, and pure DC. One for the 12 and 6 volt tubes in general, and one at 17 volts for the final tubes. That takes about 60 watts of load off the power transformer and gives more overhead for the final stage. There's a 9-volt battery here that kickstarts the remote off-on switch. So there is no 60 hertz energy in the radio whatsoever for really clean signal. The power supply transformer is not shielded. It can couple 60 hertz in the radio, so it's on about a 4-foot long cable to keep the transformer away from the rig. High-speed CW mods have been included. An 8 millisecond keying relay. Nobody can key faster than that. Adjustable breakout delay by this pot. The XIT allows tuning the CW signal. There's no TR relay. It's a receive-only relay like in the NCX3. That eliminates RFI from the transmit contact and guarantees that the relay can't fail and leave the transmitter output open. That also allows presetting the plate and load in receive, which is extremely useful. And that relay modification resulted in about a 50-watt increase in transmit power, believe it or not. This rig transmits about 180 watts CW and well over 300 PEP on sideband. The sideband system in a Drake TR3 and 4 are an absolute disaster. The filter crystals, sideband filter crystals, were no good from the start. Way too much capacitance. The filters were extremely sloppy. So I spent about $840 to get brand new state-of-the-art filter crystals from an original manufacturer in Taiwan. They are flawless. That made a much sharper filter was an absolutely flat passband. There's no passband ripple. The original microphone amps had a passband of about 400 cycles to 5,000 cycles, which is useless for sideband. So I reshaped the two stages to about 100 to 1700 hertz to pass my low-pitched voice. Because as original, my voice simply would not go through the transmitter on sideband. The bounce mixer was a disaster. It had 1 and 270 type diodes, 30 picofarad apiece, about 0.33 volts forward drop, extremely poor specs. So I built a brand new state-of-the-art precision matched 0.3 picofarad at maybe 10 or 20 millivolts drop microwave diode bridge with 10 turn precision potentiometers in place of the fixed resistors for absolutely precise matching. And the carrier leakage is now measured at about 50 millivolts at the final grids. Close-in operators report absolutely no carrier leakage and absolutely no key clicks. There are two TR relays. There's one for the small tube cathodes, which selects receiver transmit. And then the antenna relay also switches in the cathode of the finals. And that's staged so there cannot be key clicks. So that's basically a break-in delay. So this radio is essentially and verified by on-air reports, and I've put a lot of time on this rig and transmit. It is flawless. There's also a 19 CFM cooling fan up on top of the cabinet to keep the finals cool. So that's the rundown. If you heard it, you've heard one of a kind. KBYP.